As long as humans have been able to observe the world around them, they have marveled at the perfection of the universe. It is a perfect system, so much so that it has led many to ponder why it is so flawlessly calibrated. From the tiniest particles to the grandest galaxies, everything seems to be designed with meticulous attention to detail. It is an intricate tapestry of systems and laws that govern the universe's behavior, from the movements of planets to the balance of physical constants. These physical constants seem to be finely tuned to allow the emergence of life as we know it. If any of these constants were slightly different, the universe would be inhospitable and incapable of supporting the complex chemical reactions and biological processes that make life possible. But what is the purpose behind this perfect calibration? Is it a mere coincidence, or is there something more at play? Scientists have been exploring this question for centuries, and yet the answer remains elusive. Some believe that the universe's perfection is a sign of intelligent design, while others think it is simply a result of chance. Whatever the case may be, the universe's perfection remains a mystery that continues to captivate and inspire us. Despite all the chaos and destruction that has occurred in the universe, the fundamental laws of nature have remained constant, providing a stable foundation for the emergence and evolution of life. From the universe's birth in the Big Bang to its ongoing expansion and evolution, the universe has continued to develop. The universe's perfection may never be fully understood, but it is this mystery that drives us to explore and learn more about the vast and complex universe around us. Throughout human history, our understanding of the universe has evolved dramatically. For centuries, people believed in the geocentric model of the universe, which placed the Earth at the center with the sun, moon, planets, and stars revolving around it. This view prevailed until the 16th century when Polish mathematician and astronomer Nicholas Copernicus proposed the heliocentric model, which placed the sun at the center with the planets orbiting around it. Over time, the heliocentric model became widely accepted as it was supported by observations by astronomers such as Galileo. The 20th century brought significant advancements in technology and our ability to study the universe, revealing that our sun is just one of billions of stars within our Milky Way galaxy, which is just one of potentially trillions of galaxies in the observable universe. Scientists like Edwin Hubble also discovered that the universe is expanding, leading to the development of the Big Bang theory, which posits that the universe began with a massive explosion 13.8 billion years ago. These discoveries have led to the question of whether we are special in the universe. The anthropic principle is one line of thinking that attempts to answer this question. It suggests that the universe must have properties that make it possible, if not mandatory, for intelligent observers like us to arise. While the anthropic principle acknowledges the existence of fundamental laws that govern the universe, it fails to recognize that probability is relative to specific conditions. Therefore, the existence of life does not imply that the universe is perfect, and relying solely on the anthropic principle to explain the perfection of the universe ignores the fundamental goal of science, which is to understand the natural processes that shaped our universe. While we cannot say for certain whether the laws of nature have remained exactly the same since the Big Bang, the current scientific consensus is that they have been remarkably stable throughout the history of the universe. One of the key principles of modern physics is the idea of symmetry, which suggests that the laws of nature should remain consistent over time and across different regions of the universe. However, there are some theories that suggest that the laws of nature may have undergone some changes over time. For example, some physicists have suggested that certain fundamental constants, such as the speed of light or the strength of the electromagnetic force, may have varied slightly over the course of the universe's history. This is known as the varying constants hypothesis, and it remains an area of active research and debate within the scientific community. Regardless of whether the laws of nature have remained exactly the same since the Big Bang or not, it is clear that they have given rise to an incredible diversity of structures and phenomena in the universe, from galaxies and stars to planets and life itself. Exploring the nature of these laws and the way they have shaped the universe is a fascinating and ongoing quest for scientists and philosophers alike. In the early 20th century, the development of the theory of relativity and quantum mechanics provided new insights into the nature of the universe. These theories revolutionized physics and cosmology, leading to a deeper understanding of the fundamental laws of nature that govern the behavior of matter and energy. One of the key implications of these theories was that the universe was not static but expanding. This idea was first proposed by Georges Lemaitre, a Belgian cosmologist and Catholic priest, in the 1920s. Lemaitre's proposal was based on his analysis of the observed redshifts in the spectra of distant galaxies, which suggested that they were moving away from us and from each other. The expansion of the universe implied that the universe was much denser and hotter in the past, and that at some point in the distant past, all matter and energy were concentrated in a single point called the singularity. This idea formed the basis of the Big Bang Theory, which proposed that the universe began in a single explosive event that created space, time, matter, and energy. The Big Bang Theory was supported by a number of pieces of observational evidence, including the cosmic microwave background radiation, which was discovered in 1965 by Arno Penzias and Robert Wilson. This radiation was predicted by the Big Bang Theory and provided strong evidence that the universe had a hot and dense beginning. The Big Bang Theory also provided an explanation for the abundance of light elements, such as hydrogen and helium, in the universe. According to the theory, these elements were created in the first few minutes after the Big Bang, when the universe was hot and dense enough for nuclear reactions to occur. However, the Big Bang Theory also raised a number of questions and challenges. For example, it could not explain the observed large-scale structure of the universe, such as the formation of galaxies and clusters of galaxies. To address these challenges, scientists proposed the inflationary universe theory, which suggested that the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. The inflationary universe theory also provided an explanation for the uniformity of the cosmic microwave background radiation, which was observed to be almost the same in all directions. According to the theory, the universe underwent a rapid expansion during inflation, smoothing out any irregularities and creating a uniform background radiation. Despite its successes, the Big Bang Theory is still an active area of research and debate, and there are many open questions and challenges that remain. For example, the theory cannot explain the observed dark matter and dark energy, which are thought to make up the majority of the mass and energy of the universe. There is also ongoing research into the nature of the singularity and the conditions that existed in the earliest moments of the universe. In the world of physics, change is a crucial concept that has been studied for centuries. Aristotle, a Greek philosopher and scientist from the 4th century, argued that one of the primary goals of physics was to study change. This concept has remained relevant to this day, as physicists continue to explore the ever-changing nature of our universe. One of the most intriguing questions in physics is why the laws of physics are the way they are. If the laws of physics were to change over time, then physicists would need to understand the reason behind this change and formulate a new law of physics instead. This process would continue until a physical theory that is independent of time is established. However, if any of the fundamental forces of the universe were to change, the consequences would be catastrophic. In our modern universe, we have 4 fundamental forces: gravitation, electromagnetism, and the strong and weak nuclear forces. If any of these forces were to change, the results would be disastrous. For example, if the force of gravity were to change, the reliable predictions of object motion on Earth, celestial orbits within our solar system, flight paths of aircraft and spacecraft, and cosmic phenomena such as gravitational lensing and universe expansion would be virtually impossible to make. Similarly, if the electromagnetic force were to change, every molecule in the universe would alter its properties in a fundamental way. This would result in the binding properties between electrons in different atoms becoming highly uncertain, which would have catastrophic consequences. If the strong or weak nuclear force were to change, the consequences would be even more severe. Atomic nuclei would undergo spontaneous decay, releasing a tremendous amount of energy as they shifted into a more stable configuration. Bound atoms would be stripped of their electrons and transformed into ionized particles, resulting in the creation of a plasma universe in the affected region. The consequences of such a disruption to the fundamental nuclear forces would be so profound that it's impossible to fully comprehend the scale of the devastation that would result. Moreover, our universe seems to be perfectly fine-tuned to support life. However, some physicists argue that the fine-tuning of our universe is not remarkable because there may be countless other universes with different physical constants and laws of nature. This theory is known as the multiverse theory, and it is a subject of ongoing research and debate in the scientific community. In conclusion, the study of change in physics is a complex and ongoing endeavor that is essential to our understanding of the universe. The consequences of any changes to the fundamental forces of the universe would be catastrophic, and our universe's apparent fine-tuning is still a subject of ongoing research and debate. The concept of the universe's fine-tuning is a fascinating and complex topic that has captivated scientists and philosophers alike for decades. As you mentioned, Lawrence Joseph Henderson's book, The Fitness of the Environment, was among the first works to delve into the critical role of water and environmental conditions in sustaining life. This idea laid the foundation for subsequent theories on the universe's fine-tuning. Physicist Robert Dickey's postulation in 1961 that the universe's physical forces must be finely tuned to allow for life to thrive furthered the discussion on the topic. Similarly, in Fred Hoyle's 1984 book, The Intelligent Universe, he argued that numerous non-biological phenomena were essential to the existence of carbon-based life forms such as humans. Despite these competing theories, the fact remains that our universe is remarkably consistent and well-ordered, with physical laws that hold true from the smallest particles to the largest structures. The ratio of the strong force to the electromagnetic force is just right to allow for the formation of stars and galaxies, and changing this ratio even slightly would preclude any life in the universe. The question then arises, what does all of this mean for us? The universe's fine-tuning suggests that there is something special about the universe and the way that it operates, which points to a sense of purpose or meaning that extends beyond our individual lives and experiences. It reminds us that we are part of something much larger and more intricate than we could ever fully comprehend. The search for a theory that can link up everything in the universe, like a magic theory, as you put it, is one of the biggest challenges facing scientists today. The Large Hadron Collider was expected to uncover evidence of physics beyond the standard model, such as supersymmetry, but by 2012, it had not yielded proof of supersymmetry at the energy levels it was capable of probing. In conclusion, the concept of the universe's fine-tuning is an exciting and thought-provoking area of study. It reminds us of the incredible mystery and beauty of the world we live in and our place in the grand scheme of things. As we continue to explore and study the universe, we may uncover even more fascinating insights into its remarkable consistency and order. The remarkable consistency and fine-tuning of the universe have led many to believe that there is something special about its operation, which extends beyond our individual experiences. Physicists and scientists have long been fascinated by the mystery of the universe and have searched for a theory that can link up everything in it like a magic theory. While competing theories abound, there is no denying the fact that the universe is indeed well-ordered, and its physical forces are finely tuned to allow for life to thrive. The contributions of scientists like Lawrence Joseph Henderson, Robert Dickey, and Fred Hoyle have helped shed light on the critical role of water, environmental conditions, and numerous non-biological phenomena in sustaining life. As we look up at the night sky and marvel at the perfection and consistency of the universe, we are reminded of the incredible mystery and beauty of the world we live in and of our place in the grand scheme of things. It points to a sense of purpose or meaning that extends beyond our individual lives and experiences. While we may never fully comprehend the universe, we can appreciate its beauty and be grateful for the opportunity to be a part of it. The pursuit of understanding the universe and finding a theory that links everything up remains one of the greatest challenges and adventures of our time. Thank you for watching and taking the time to explore the fascinating concept of the universe's fine-tuning. It is truly remarkable to consider the precision and consistency with which our universe operates, and it reminds us of the incredible mystery and beauty of the world we live in. Whether you are a science enthusiast or simply marvel at the wonders of the cosmos, I hope this video has given you some insight and inspiration. Don't forget to subscribe to my channel for more videos like this one, and I'll see you in the next one. Thank you again for your support.